Hello students, welcome to my YouTube channel. Today we will see class 9 subject science chapter 5 acids, bases and salts exercise solutions of question 5 to question number 10. So question 5, show the dissociation of the following compounds on dissolving in water with the help of chemical equation and write whether the proportion of dissociation is small or large. Hydrochloric acid, sodium chloride, potassium hydroxide, ammonia, acetic acid, magnesium chloride, copper sulphate. Answer A. Hydrochloric acid HCl. HCl water dissociation gives H plus Cl negative. Hydrochloric acid is a strong acid as on dissolving in water it dissociates almost completely. The resulting aqueous solution contains mainly H plus ions and the concerned acidic radical. The proportion of dissociation is large. B. Sodium chloride NaCl. NaCl gives Na plus Cl negative. When an ionic compound begins to dissolve in water, the water molecules push themselves in between the positive and negative ions of the compound and separate them from each other. The proportion of dissociation is large. See potassium hydroxide KOH. KOH gives K plus OH. Potassium hydroxide is a strong base as on dissolving in water it dissociates almost completely and the resulting aqueous solution contains mainly OH plus ions and the concerned basic radical. The proportion of dissociation is large. D. Ammonia NH3. NH3 NH3 gives NH4 plus OH negative. Proportion of dissociation is small. Next E. Acetic acid. CH3COOH gives CH3COO plus H plus. Acetic acid is weak acid on dissolving in water. It does not dissociate completely. The resulting aqueous solution contains H plus ions and the concerned acidic radical in small proportion along with large proportion of undissociated molecules of acid. The proportions of dissociation is small. F. Magnesium chloride MgCl2. MgCl2 gives Mg2 plus 2 Cl negative. Magnesium chloride dissolves in water and forms magnesium ions and chloride ions. The proportion of dissociation is large. G. Copper sulphate CuSO4. CuSO4 gives Cu2 plus SO4 2 minus. When copper sulphate is dissolved in water, it forms copper ions and sulphate ions. The proportion of dissociation is large. Question 6. Write down the concentration of each of the following solution in gram per liter and mole per liter. A. 7.3 gram HCl in 100 ml solution. B. 2 gram NaOH in 50 ml solution. C. 3 gram CH3COOH in 100 ml solution. D. 4.9 gram H2SO4 in 200 ml solution. Answer. Hydrochloric acid molecular formula HCl. Molecular mass 36.5 U gram. 7.3 gram mole 0.2 mole F 100 ml is equal to 0.1 liter. Concentration of the solution 7.3 gram per liter. Molarity 2 mole per liter. Sodium hydroxide molecular formula NaOH. Molecular mass 40 U. Quantity of solute gram 2.0 gram mole 0.05 mole. Volume of solution 50 ml is equal to 0.05 liter. Concentration of this solution G 40 gram per liter, H 1 mole per liter. Acetic acid C molecular formula CH3COOH. Molecular mass 60 U. Quantity of solute gram 3.0 gram. mole 0.05 mole. Volume of solution 100 ml is equal to 0.1 liter. Concentration of solution 30 gram per liter, 0.5 mole per liter. Sulfuric acid molecular formula H2SO4, molecular mass 98 U, quantity of solute gram 4.9 gram, mole 0.05 mole. Volume of solution 200 ml is equal to 0.2 liter. Concentration of solution 24.5 gram per liter, 0.25 mole per liter. Question 7. Answer the following questions. A. Classify the acids according to their basicity and give one example of each type. Answer. Basicity of acids. The number H plus ions obtainable by the dissociation of one molecule of an acid is called its basicity. The acids are classified as monobasic, dibasic, and tribasic acids based on the number of H plus ions present. Examples of monobasic acid HCl, HNO3, CH3COOH. Examples of dibasic acid H2SO4, H2CO3, and examples of tribasic acids H3BO3, H3PO4. Next question B. What is meant by neutralization? Give two examples from everyday life of the neutralization reaction. Answer. In neutralization reaction, an acid reacts with a base to form salt and water. In a neutralization reaction, the acid dissociates to form H plus ions and base dissociates to form OH ions. They combine to form H2O molecules which mixes with the solvent. Examples in daily life. When people suffer from acidity, they take some antacids to neutralize the acid in their stomach. If an ant stings us, the pain is due to formic acid. It is neutralized by rubbing moist baking soda, which is basic in nature. Question C. Explain what is meant by electrolysis of water. Write the electrode reactions and explain them. Answer. Electrolysis of water. Electrolysis of water is the decomposition of water into oxygen and hydrogen gas due to an electric current being passed through acidified water. Cathode reaction. Twice H2O plus twice E negative gives H2 plus twice OH. Anode reaction. Twice H2O gives O2 plus 4H plus 4E negative. It is found that the volume of gas formed near the cathode is double that of the gas formed near the anode. Hydrogen gas is formed near the cathode and oxygen gas near the anode. From this, it is clear that electrolysis of water has taken place and its constituent element have been released. Next, question 8. Write the chemical equations for the following activities. A. NaOH solution was added to HCl solution. Answer. When NaOH reacts with HCl, it gives NaCl and water. NaOH plus HCl gives NaCl plus H2O. B. Zinc dust was added to dilute H2SO4. Answer. When zinc reacts with dilute sulfuric acid, it forms zinc sulphate and hydrogen gas is liberated. Zn plus H2SO4 gives ZnSO4 plus H2. C. Dilute nitric acid was added to calcium oxide. Answer. When dilute nitric acid reacts with calcium oxide, it forms calcium nitrate and water. Twice HNO3 plus CaO gives CaNO3 by 2 plus H2O. E. Carbon dioxide gas passed through KOH solution. And answer. When carbon dioxide gas passes through KOH solution, it forms potassium carbonate and water. CO2 plus 2KOH gives K2CO3 plus H2O. E. Dilute HCl was poured on baking soda. Answer. When dilute HCl was poured on baking soda, it forms sodium chloride and carbon dioxide gas. NaHCO3 plus HCl gives NaCl plus H2O plus CO2. Question 9. State the differences. Acids and bases. Answer. Acids bases. A substance which liberates H plus ions when dissolved in water is an acid, and a substance which liberates OH negative ions when dissolved in water is called a base. Blue litmus turns red in an acid. Red litmus turns blue in a base. The pH of an acid is less than 7. The pH of a base is greater than 7. Acids are sour to taste. Bases are bitter to taste. Examples of acids are HCl, H2SO4, and examples of bases are NaOH, KOH. B. Cation and anion. Answer. Cations are ions with a net positive charge. Anions are ions with a net negative charge. Cations are generally formed by metals. When metals donate electrons, they have excess of protons, hence they form cations. Anions are generally formed by nonmetals. When nonmetals accept electrons, they have excess of electrons, hence they form anions. Third, cations are attracted by towards the cathode, which are negatively charged electrons. Anions are attracted towards the anode, which are positively charged electrodes. Cations examples Na plus, Ca2 plus, Mg2 plus, K plus. Anions examples O2, S2 negative, Cl negative, Br negative. Next, the negative electrode and the positive electrode. Answer. Negative electrode, positive electrode. First, negatively charged electrodes are called as a cathode. Positively charged electrodes are called as anode. Positively charged cations move towards the cathode or negative electrode. Negatively charged anions move towards the anode or positive electrode. Cathode accepts electrons from cations. Anode gives electrons to anions. Question number 10. Classify aqueous solutions of the following substances according to their pH into three groups: 7, more than 7, less than 7. Common salt, sodium acetate, hydrochloric acid, carbon dioxide, potassium bromide, calcium hydroxide, ammonium chloride, vinegar, sodium carbonate, ammonia, sulfur dioxide. Answer. Substances whose pH is equal to 7. Common salt, potassium bromide. Substances whose pH more than 7. Sodium acetate, sodium carbonate, ammonia, calcium hydroxide. Substances whose pH is less than 7. Sulfur dioxide, hydrochloric acid, carbon dioxide, ammonium chloride, vinegar. Acids, bases and salts exercise completed. If you like this video, then please like, share and subscribe to my YouTube channel. Thank you.